Hello, welcome to Unit 6, Lesson 6. I'm Professor Blackman. In this lesson, we're going to be talking about solving radical equations. When we're working with radical equations, the big thing that we want to do is we want to isolate them. We want to get them to one side, whether it be the left or right, doesn't matter. And then once we do that, then we're going to apply the power. So if it's square, we're going to square it. And once that happens, if there's only one radical, we're good. If there's two radicals, then we got to do it again. And then it's very important that we check our problems, because if it's not in the domain, then we will not be able to have a solution. We'll have to write it as no solution. Let's go ahead and try some examples. All right, so in this example, you can see that the radical is already isolated. So we're going to start by squaring it. And if you square one side, you have to square the other side. So squaring the square root cancels it out. So then we get 2x minus 3 equals 16. Add 3 to both sides, and that gives us 2x equals 19. Divide by 2, and x equals 19 over 2. And then we can go and check that. So we're going to plug that into the square root. 2 times 19 over 2 minus 3 needs to equal 4. 2's cancel. 19 minus 3, and that's square root of 16, which equals 4. And as you see, the left side equals the right side, so this is our solution. All right, we can see that the radical is isolated, so let's go ahead and square both sides. And then we get 5y plus 8 equals 100. Subtract 8, and we get 5y equals 92. Divide by 5, and you get y equals 92 over 5. And then we go and check that. Plug that in. 5 times 92 over 5 plus 8 needs to equal 10. 5's cancel. 92 plus 8 is 100, which gives us 10. So you can see the left side equals the right side. So this is our solution. All right, let's look at another example. Okay, so this one, you can see that it's cubed. So instead of squaring it like we did in our previous examples, we need to cube this one. So cubing a cube root cancels it out. So then we get x plus 5 equals 8. Subtract 5 from both sides, and x equals 3. We can check that. So we plug in that 3, and we get 3 plus 5. Take the cube root of that, and that needs to equal 2. Cube root of 8 does in fact equal 2. So the left side equals the right side. All right, let's look at our next example. So yeah, as you see here, this is our first one where the radical is not isolated, but we can change that very quickly by adding 2 to both sides. So then we have the square root of 2x plus 7 on the left, and on the right side we have x plus 2. And so now when we have it isolated, we can square both sides. On the left, we get 2x plus 7. On the right, we get x squared plus 4x plus 4. Now, if you don't know where that comes from, we can write it out. X plus 2 squared is x plus 2, x plus 2, which is x squared plus 2x plus 2x plus 4, and the middle becomes 4x. So that is where that comes from. All right, let's continue working the problem. All right, so this is a quadratic, so we need to zero out one side. So we're going to subtract 2x, subtract 7. We get 0 equals x squared plus 2x minus 3. And then we're going to solve that by factoring. And we get x plus 3, x minus 1. Set each of those factors equal to 0. And we get x equals negative 3 and x equals 1. So these are solutions that we definitely need to check. So let's check the first one. X equals negative 3. If we plug that in, we get 2 times negative 3 plus 7 minus 2 needs to equal negative 3. And 2 times negative 3 is negative 6 plus 7 equals 1. So square root of 1 minus 2 equals negative 3. 1 minus 2 equals negative 3. Negative 1 equals negative 3. So this is not a solution. Check x equals 1. Plug that in. 2 times 1 plus 7 minus 2 needs to equal 1. 2 times 1 is 2 plus 7 gives you 9. So we have square root of 9 minus 2 equals 1. 3 minus 2 does in fact equal 1. So this is our only solution. This is what we call an extraneous solution. All right, let's look at another example. All right, so let's isolate the radical. So we're going to add 1 to both sides. So now we have 3 square root x minus 1 equals x plus 1. So let's square both sides. And squaring the thing in front, that 3 will give us a 9, x minus 1, and then x squared plus 2x plus 1. And if you don't know where that comes from, look at my previous example. Distribute the 9, we get 9x minus 9 equals x squared plus 2x plus 1. It's a quadratic, so 0 out one side. So subtract the 9x, add the 9, and we get 0 equals x squared minus 7x plus 10. So this becomes 0 equals x minus 5, x minus 2. If you don't know where that x minus 5, x minus 2 came from, go and watch my videos on factoring. So then we get x minus 5 equals 0. X minus 2 equals 0. So x equals 5 and x equals 2. And again, since this is a radical equation, we need to make sure we check it. So let's check. And if we plug in 5, we get 3. 5 minus 1 equals 5. So that's 3 times the square root of 4 minus 1 equals 5. Square root of 4 is 2 times 3 gives us 6 minus 1 equals 5, which does in fact 5 equals 5. So this is a solution. Now let's check x equals 2. Plug in 3. 2 minus 1 needs to equal 2, and that's 3. Square root of 1 minus 1 equals 2. Square root of 1 is 1 times 3, so 3 minus 1 equals 2. So we get 2 equals 2. So this is also a solution. So we can put those solutions together. X equals 2 and 5. All right, let's look at the next one. We do have the radical isolated, so we can start by just squaring both sides. And we get x squared minus 6x plus 9 equals 27 minus 3x. 0 out one side by subtracting 27 and adding 3x. And we get x squared minus 3x minus 18. And then we factor this, And that gives us x minus 6, x plus 3. Set each factor equal to 0. X plus 3 equals 0. And then that gives us x equals 6 and x equals negative 3. Now, of course, this is a radical equation, so we definitely need to check that one. So let's check x equals 6. And that will give us 6 minus 3 equals square root of 27 minus 3 times 6. So left side we have 3. 27 minus 18 gives us 9, so we have 3 equals 3. So that is correct. Now let's check negative 3. And negative 3 minus 3 equals 27 minus 3 times negative 3. So over here we have negative 6, and we have 27 plus 9. Negative 6 equals square root of 36. Negative 6 equals 6. That is not true, so this is not a solution. So our only solution is the x equals 6. All right, let's look at some more examples. So this is our first example with two radicals. Well, we first start by isolating one of them. So I'm going to add square root of y minus 2 to both sides. And after I do that, then I will have the square root of 4y plus 1 on the left side, and 3 plus the square root of y minus 2 on the other side. And now once the one radical is isolated, I can square both sides, and I get 4y plus 1 on the left side. But on the right side, I'm going to have to show that multiplication. I don't want to try and do this in my head. And so 3 times 3 is 9, then plus 3 radical y minus 2, plus 3 radical y minus 2, plus radical y minus 2 squared, because you're multiplying by itself, gives you y minus 2. Simplify that, and you get y plus 7 plus 6 radical y minus 2, which we write over here. Y plus 7 plus 6 radical y minus 2. So unlike before, we still have a radical. So we need to isolate the radical again. So we subtract y from both sides. We subtract 7 from both sides. And we get 3y minus 6 equals 6 radical y minus 2. Now that it's isolated again, we can square both sides. And let's go ahead and show the 3y minus 6 squared multiplication, which is 9y squared minus 18y minus 18y plus 36. 9y squared minus 36y plus 36. Plus 36. And when we square the right side, we get 36 times y minus 2, which we need to distribute, and we get 36y minus 72. And on the left side, we're just going to bring that down. And since we have a quadratic, we need to zero out one side. So subtract 36y from both sides, add 72 to both sides. And we get 9y squared minus 72y plus 108 equals right side 0. I can see that all those are multiples of 9. So I'm going to divide everything by 9. If this was factoring, I would have to factor out that 9. But since we're solving, we can divide both sides by 9. And that gives me y squared minus 8y plus 12 equals 0. which I can factor. I'll rewrite it again. Ran out of room at the bottom of my screen. And that will factor to y minus 6, y minus 2 equals 0, which we can set each factor equal to 0. And we get y equals 6 and y equals 2. Now, this is again a radical equation, so we need to check our solution. You should really check all your solutions, but with radicals and rationals, you have to. Let's check y equals 6 first. And we get 4 times 6 plus 1 minus 6 minus 2 needs to equal 3. 24 plus 1 is 25. Square root of 25 is 5. Minus 6 minus 2 is 4. Square root of 4 is 2. And that needs to equal 3. And it does equal 3. So this is a solution. Now let's check 2. We're going to plug that in for y equals 2. And we do square root 4 times 2 plus 1 minus square root of 2 minus 2 needs to equal 3. 4 times 2 is 8 plus 1 gives us 9. Square root of 9 is 3. Minus 2 minus 2 is 0. Square root of 0 is 0 equals 3. And 3 does in fact equal 3. So we have that as a solution. Since they are both solutions, we can write that as y equals 2 and 6. All right, let's look at another example. All right, let's go ahead and subtract square root of x plus 2 from both sides. It does not matter which one you subtract, so I just went with the easiest one to subtract. And now we get square root of 3x plus 4 equals 2 minus x plus 2. Square both sides now. And we get 3x plus 4 equals, and let's do that math over here. And multiply it by itself. And then we get 4 minus 2 x plus 2 minus 2 root x plus 2. And negative times negative would be positive x plus 2. Add that all together, and we get x plus 6 minus 4 root x plus 2. So bring that over. All right. And now we need to isolate the root again. So we're going to subtract x, subtract 6, subtract 6, and we get 2x minus 2 equals negative 4 root x plus 2. And square both sides. And we get 16 times x plus 2 on the right. And on the left, we'll go ahead and do that math over here. Multiply by 2x minus 2 by itself. And that gives us 4x squared minus 4x minus 4x plus 4. And that will give us 4x squared. Middles combined to negative 8x plus 4. And then we write that in over here. Minus 8x plus 4. Distribute your 16, you get 16x plus 32. Copy down the left side. And now since we can see that it is a quadratic, we're going to isolate the quadratic on one side so we can zero out the other side. So let's subtract 16x for both sides and subtract 32. And when we simplify that, we get 4x squared minus 24x minus 28 equals 0. And you can see all those are multiples of 4, so we're going to divide both sides by 4. Now, when we were factoring, we would have to factor out the 4 as a GCF, but since we're solving, we can divide by 4. and that gives us x squared minus 6x minus 7 equals 0. So that is x minus 7, x plus 1 equals 0, which we set each factor equal to 0, and that gives us x minus 7 equals 0, and x plus 1 equals 0. So that's x equals 7, and x equals negative 1. And again, because this is a radical equation, we need to check our solutions. So let's start by checking x equals 7, and that will give us the square root of 7 plus 2 plus square root of 3 times 7 plus 4 needs to equal 2. 7 plus 2 is 9. Square root of 9 is 3. Plus 3 times 7 is 21. Plus 4 gives you 25. Gives you 5. And that equals 2. 8 does not equal 2. So not a solution. Let's check negative 1. And we get negative 1 plus 2 plus 3 times negative 1 plus 4 needs to equal 2. Negative 1 plus 2 is 1. Square root of 1 is 1. Plus negative 3 plus 4 is 1. Square root of 1 is 1. And 1 plus 1 does equal 2. So this is our solution. X equals negative 1. That's all I have for you today. Happy study.